All right, today we are digging into something really different. A radical new blueprint for artificial intelligence, an OS that's designed not just to think, but to actually evolve itself. And it all kicks off with a question that kind of turns everything on its head. We're so used to thinking that to make things better, we have to add more stuff, more features, more complexity. But what if the real path forward, the way to build truly powerful intelligent systems, is to do the exact opposite? And this right here, this slide just lays it all out. On one hand, you have the old way, building these fragile, brittle systems that need constant patching and maintenance. But the new paradigm? It's all about making things anti-fragile. Like a muscle that literally gets stronger from stress and disorder. The whole goal is to build a system that gets better by cutting away everything that isn't absolutely essential. So here's how we're going to tackle this. We're going to start with the big idea, the great inversion. Then we'll look at the architecture of intelligence itself. After that, we'll see how it thinks using the cognitive assembly line, how it keeps itself healthy with an OS with immunity, and finally, the really wild part, how it grows with the evolution engine. Okay, first up, the great inversion. Let's really get into the core problem that this entire architecture was built to solve. The big issue with AI today is this thing the source material calls the friction wall. You see, to try and make our models safe, we just keep wrapping them in more and more layers of code, filters, and guardrails. And it doesn't just slow things down, it makes the whole system incredibly fragile. Every new patch we add is just another thing that can break. So, if that's the problem, how does this blueprint actually fix it? Well, it starts by completely rethinking what the architecture of intelligence should even look like. And the solution is called the Dual Stack Intelligence Engine, or DSIE. And this is really the heart of the whole design. The easiest way to think about it is like a brain with two completely separate parts, a creative, almost chaotic part, and then a super disciplined, logical part that's obsessed with safety. So the first half is the probabilistic stack, and they call it the dreamer. This is the engine of pure creativity. It's where all the novel ideas, the crazy solutions, the out-of-the-box thinking happens with absolutely zero constraints. And then you have its polar opposite, the deterministic stack, or the guardian. This thing is a small, ruthlessly logical safety kernel. Its only job is to check the dreamer's ideas against a hard-coded set of rules. It can't create anything. All it can do is say yes or no. And how these two work together is what's so brilliant. It's called the inversion of execution. So first, the dreamer comes up with a creative plan. Then that plan gets translated into a formal machine-readable contract. And only then does the guardian check it. If and only if that contract passes every single safety check, is the action allowed to happen. So you see, safety isn't some afterthought. It's the gateway for every single action. Okay, so that's the safety architecture. It's pretty solid. But how does the dreamer part actually generate those breakthrough ideas in the first place? Well, it uses this incredible four-agent system, kind of like a cognitive assembly line. This is the mixture of inversion experts framework. It starts with the inversion critic, which takes a problem and just flips all the common assumptions on their head. Then the hunter goes out and finds weird outlier data that actually supports this new crazy view. Next, the alchemist takes all those pieces and synthesizes them into a totally new solution. And finally, the judge acts like a built-in red team, doing everything it can to find flaws and break the new idea. It's this constant cycle of adversarial cooperation that leads to real breakthroughs. Having a brilliant mind isn't enough. The system also has to maintain itself to fight off the natural tendency to get bloated and complex over time. Basically, it needs its own digital immune system. And that immune system runs on one simple metric, the vitality to density ratio, or VDR. You can think of it like a constant metabolic checkup for every single piece of the system. It's always asking, hey, is the value you provide worth the complexity and the resources you're costing us? Which, you'll notice, brings us right back to that core theme we started with. The whole system improves itself, not by adding more junk, but by relentlessly getting rid of what's not working, until only the truth is left. The system actually acts on that VDR metric, using something called the Ouroboros loop. So if any component, could be a feature, a model, anything, has its VDR drop too low, a subtraction algorithm just automatically removes it. It's literally a self-pruning system that keeps everything lean, efficient, and anti-fragile. Okay, so we've got a safe architecture and a self-healing immune system. The last piece of this puzzle is the evolution engine. And this is where things get truly mind-bending, because this allows the system to improve itself on its own without ever losing touch with reality. A huge risk with any evolving AI is that it just kind of drifts off into its own little world, right? It becomes delusional. To stop that, this system uses what's called a reality coherence term. You can think of it like a cryptographic chain tying it to the real world. This pipeline is constantly checking. Do the system's predictions match up with what's actually happening out there? If they don't, it gets penalized. And the evolution process itself follows one simple, incredibly powerful rule: the recursion rule. It says that any change the system makes to its own code must either reduce its overall complexity or it must demonstrably increase its ability to get stronger from chaos. In other words, every single change has to be an improvement, period. And when you put all of these concepts together, the dual stack, the cognitive assembly line, the immune system, the evolution engine, you get the final blueprint, MoIE OS version 1.4. This isn't just a white paper idea, it's a complete, buildable design for an autonomous adversarial evolution kernel, spelled out with everything from modules to sequence diagrams. Which leaves us with a pretty massive question to think about. We've spent our entire history building tools that need us to constantly fix and maintain them. So what becomes possible for science, for exploration, for us, when our most powerful tools can not only hear themselves, but actively evolve themselves into something better?